Hello everyone. Today is the last session in section 1-4 in our calculus class on continuity. So in this lecture, I will be talking about the intermediate value theorem. So what is an intermediate value theorem? Here, you're given a function f. There are three conditions which are needed for an intermediate value theorem. The first one, the function has to be continuous on a closed interval. The values at the end of the interval, that is f of a and f of b, should be different. And if k is any number between the function value at a and b, then by the intermediate value theorem, there is at least one number c in the closed interval such that f of c equals k. Now, let's look at from a graphical point of view, the same thing. Okay, so here is a function which is continuous on a closed interval, a to b. And notice that the value of the function at a is different than the value of the function at b. Then, and if there is a value, third thing was there's a value in between f of a and f of b, k, such that we will be able to find some value. This is at least one c. So here we end up getting three c's, c1, c2, c3, such that f of c1 is k, f of c2 is k, and f of c3 is k2. Now this intermediate value theorem, let's talk some of the observations. Now this intermediate value theorem, which is going to be basically IVT, I'm going to use that an abbreviation here. This is concerned with the behavior of the function in a closed interval. And it is very often used to find the zeros of the function. If you have forgotten what's the zero of the function, it's a zero of the function are those values of the function where the function is 0. In other words, suppose x1 is a 0 of a function, say fx. What does that mean? It means f of x1 is 0. For example, let's look at that. Because this is what we'll be also doing a little bit later on, zeros of the function. This is, for example, if we have a graph, say let's talk about a function fx. So fx is, say, x squared minus x and minus, let's say, what should we put? So x squared minus x minus, say, 6. Now clearly we know if I plug in say 3, what happens? 3 squared is minus 3, so we have 9 minus 3 minus 6, it's a 0. Now if you plug in f of minus 2, what do you notice? So minus 2 the whole square, minus of minus 2, minus 6. You have 4 plus 2 minus 6, again a 0. So basically, the zeros of the function are x equals 3 and x equals minus 2. And also if you look at from the graph of the function, this is how the graph goes. Sorry guys, I'm not so, okay, great. It's not, you can see my drawing capabilities are not so great, but we will try our best. Okay, so assume this is minus 2 guys and this is minus 3. This is your function f of x. Now, the zeros of the function are also basically the x-intercepts of the function. That's what basically IVT really helps. If the function is continuous on a closed interval, then it helps us to locate the zeros of the function. So this is the whole story. And we will be, as I said later on, we will be using this IVT to find the zeros of the function. Okay, also when we apply the IVT to locate the zeros, we have to make sure of one of the most important things, that f of a not only should be equal to f of b, the signs should be different. For example, we just had this example of f of x equals x squared minus x minus 6. And notice what basically it means is, so if I'm having a graph here, this is minus 2 and 3. Notice here, so if I'm taking this interval, say minus 4 to 0, notice what happens. If you have values, so if I'm taking minus 4 and 0, so f of 0 is somewhere a negative value and f of minus 4 is somewhere a positive value. So clearly, not only the values at the endpoints are different, but there also is the difference in sign. And that's the key point to find the zeros of the function. Okay, now let's go ahead, do some examples. Now we're going to verify that the intermediate value theorem IVT applies to the function x squared plus x minus 1 in the closed interval 1 to 3. Also, we would find the value of c, which is guaranteed by IVT, where f of c equals 5. Now, whenever you're doing these problems, guys, it's very important to make sure that the conditions are well met. The conditions for an IVT is it has to be continuous on a closed interval and the endpoints should be different values. So, we have to mention that. And you make sure you do that in the exams and the quizzes or whatever kind of questions I give you in the class. So make sure you write down the function is continuous and they are different values. I need to see that. That's a part of your grade too. Okay, coming back here. Clearly, we see that the function is continuous on the closed interval. It's a polynomial. Every polynomials are continuous. We know that. Now let's look at the value of the function at 1, which is 1. And look at the value of the function at 3, which is 11. Okay, now clearly the two conditions, continuity and the values function are different, or f of 3 it should be, guys. It's a typo. Now, by IVT, there exists a number c in 1, 2, 3 closed interval such that f of c is 5. Now, we want to find this c, which will give me f of c to be 5. So, just a simple math now, f of c is 5. Now remember the function is given to be x squared plus x minus 1. Replace x by c, you get c squared plus c minus 1 equals 5. And you get the 5 on the left hand side, you get c squared plus c minus 6 to be 0. And you get c plus 3, c minus 2 to be 0. And the values are c is minus 3 and c is 2. Now, remember, we're looking in the interval 1, 2, 3. So only c equals 2 is the valid one for us. Okay, so we have done this one. Now let's go and apply the zeros, remember? Okay, this next question says, apply IVT to approximate the zero of the function fx equals x squared minus 6x minus 7 in the interval 6 to 8. Clearly, this function is continuous on the closed interval 6 to 8. The value of the function at 6 is minus 7 and 8 is 9. Not only these values are different, but they have different signs too. 6 is negative and 8 is positive. Now by IVT, there is a number c in the interval 6 to 8 such that f of c is 0. Now that's the meaning of the zeros of the function. Remember, I just explained to you with an example what a 0 is. That's what basically I'm saying. So go ahead, do the math. F of c is 0. Remember, f of x is here. So replace the x's by c. You get c squared minus 6c minus 7. You can write this as c minus 7c plus 1. You all know how to factor it out, which gives us two values for c, 7 and minus 1. But remember, we're looking in the interval 6 to 8. So the value c equals 7 is the zero of the function and it is guaranteed by IVT. And as usual, guys, when we do some examples, we learn concepts. What do? We practice. So that's for you guys to practice these two questions. Thank you.